Our final class example, 1.55, will ask us to place restrictions on a function so that its inverse is also a function. This question isn't particularly challenging, but students often misunderstand what it's asking. Here we've been given a parabola, f of x equals x plus 3 squared minus 2. It is a function. However, if we graph its inverse, we can see that it is not a function. This is because the original fails the horizontal line test, and consequently, the inverse fails the vertical line test. Now, students who misunderstand the question will think it's saying to restrict the domain of the inverse so it is a function. But that's not possible here unless we simply erased the entire function. However, we can place restrictions on the domain of the original blue graph such that the inverse will be a function. As an example, if we restricted the domain to only the right half of the parabola, then our blue graph would look like this. This is the domain of all values of x greater than or equal to 3. And as a result, the inverse, which is the green graph, would no longer fail the vertical line test. Now it is a function. However, this domain is not a unique solution. Another option would be for us to keep all points to the left of positive 3. We still have only half of a parabola, and so our inverse is, in this case, the bottom half, as though it were a negative radical function. But again, this is not the only other solution. Now, we could get crazy and creative and just start making up numbers. But what's important is you understand conceptually what's going on here. If we keep any part of both halves of the parabola, then our original graph will fail the horizontal line test and our inverse will fail the vertical line test. As long as we keep half the parabola or only a portion of that half, then we will pass the horizontal line test originally and the vertical line test in the inverse. So there are actually an infinite number of answers to this question. X could be greater than or equal to 3, greater than or equal to 4, greater than or equal to 5. It could even be between positive 3 and positive 5. However, it couldn't be an answer like x greater than or equal to 0, because that domain would still include some part of both the left and right half of the parabola. So again, as long as you are to the right of positive 3 with nothing left of it, or you are left of positive 3 with nothing to the right of it, you will have an inverse that is a function. Having said all of that, could you find a possible domain for part B so that its inverse would be a function? Here, I've listed 3 possible options that would limit the original graph in such a way that it would pass a horizontal line test. Notice in none of the options that I keep anything between positive 2 and positive 5. Because that section of the graph is a horizontal line, in the inverse it will always be a vertical line, which in itself would fail the vertical line test. However, keeping from negative 7 up to positive 2, or less than that, such as negative 1 to positive 2, or even that section on the right from 5 to 7, would all generate functions whose inverses would also be functions. A challenging question.